Welcome everyone to this new first flight event in which we are going to be showcasing what this project is about and as always giving you some recommendations for you to participate and be able to find those nasty bugs and vulnerabilities we all hate. On today's event, we are going to have a really interesting project which are going to be delving into a field that is really important, which is mathematics. You know, when you start your journey as a software developer or when you join the industry, most of people always tell you that you don't need to know math to actually succeed. And that is kind of true because when you start creating your first lines of code, you are not going to need to know how to do advanced math, but there is a 5% of the time that knowing math will make the difference from a junior slash newcomer developer, in this case, security researcher, and an actual senior one, which has the ability to solve anything. So to start, let me present to you what this project is about. So I'm going to share my screen over here, and I already had the code open. Let me go to my browser. This project, or this first slide, is called Math Master. And Math Masters are the titans of the algebraic and gas efficient. This small library of hyper-optimized functions helps to allow developers to make better code bases. So basically what this project is about. Before we start, as always, please be sure you check the nslog, the complexity scored, and as well, clone the repo and install the dependencies. And once you have that, let me showcase you what this project is about. So let's go to Visual Studio Code, and here we have it. So basically, Math Masters, as I said, is a library which has some interesting functionalities. First, we define WAD or WAD, which is a fixed point decimal with 18 decimals for basic quantities, example balances. You know, a lot of currencies on Web3, especially those under the EVM, work with 18 decimals. So this is just a fixed point decimal for that. And we have just 3 functions on this project. First, we have mulwat, which takes 2 input parameters, to uint256, and divides them by the what. Let me show you on the README. So basically, it multiplies x multiplied by y, and it divides to the number of decimals, but rounded down. And mulwhat up does exactly the same, but rounds the number up. Finally, we have another function called sqrt, which, if you are familiarized with other programming languages, is commonly used to define the square root of x, being x any variable you input to that function. This project is meant to be used for gas optimization. It means that we are not going to use just regular Solidity, but instead we are going to be using assembly directly. So this project is for you to hone up your skills on FOSS testing and, of course, on formal verification to verify the math is working as is expected to work. So let's get started with the first step you always follow. Once you clone the repo, I hope you already did using the documentation on the repo. And let's first always install the dependencies with make install. And then we can, as always, make test. And this is going to run all the tests we have for this code base. Something interesting that you are going to find here is that if we used forge coverage, we are going to have something like this. That we have 0 coverage on all the functions on this smart contract / code. Don't worry about this. This seems to be a problem with Foundry because it's freaking out, because if you check the actual code, let me show you, this is not exactly a smart contract, but a library. And Foundry seems to have a lot of troubles with the coverage functionality when you're dealing with libraries. Maybe if you are watching this and you want to send a PR to Foundry solving this issue, it might be great for your resume. But basically, if you go to the test parts, we actually have a coverage of all those tests. Something extra that you might always do when you start your journey trying to find the security vulnerabilities is find how the code base works. So something common is to use the extension solidity metrics and trying to understand deeply the code base. Something that you are going to find here, as this is a simple library with just 3 functions, we don't have any sort of inheritance or calling other dependencies, etc., etc. So how you can actually audit and find vulnerabilities for this type of smart contracts? Well, as I said, this is your opportunity to hone up your formal verification skills. Besides manual verification, on which you are limited by your human eye, it means that you may miss something. Formal verification verifies the inner mathematics of whatever you are trying to do. So they are like a more bulletproof way to audit your smart contracts. And something that you might notice here is that, as I said, we are using assembly directly into the code. And you know what? Maybe you are a smart contract developer with not advanced knowledge or assembly, or you don't know like where to start or how to understand this code. Well, this is why AI exists. Yeah, sorry for that pause. I was wanting to say that for this kind of situations, if you don't know how a specific code works, then you can use a tool like ChatGPT and just paste the code as I did here and ask it to explain you what the code is about. Because before you start performing the formal verification, you need to actually understand what the code is about. Again, at the end, the inner logic of these functions is just a simple multiplication divided by the number of decimals rounded down, and the same multiplication but rounded up. And the same goes for the square root. But again, as I said, we are using assembly code here, which might be some sort of intimidating for newcomers. So what kind of bugs or vulnerabilities we hope you find on this first flight? Well, we want you to find incorrect storage of slot packing, overriding the solidity free memory pointer. If you don't know what the solidity free memory pointer is, we included a link so you can always check. Also, you are going to have a better understanding on these codes we use for the different types of storage in bytes. And we also want you to find any out of gas errors. You know, one of the interesting things of using assembly directly into the code is that you have the total control of it. It means that you can tinker directly with all the functions the EVM is going to be interacting with. However, as Uncle's bed would said, with great power comes great responsibility. And messing up with just a little small portion of the code using assembly directly interacted with the AVM would also result on a giant mess for you. Also, we want to find incorrect use on function selectors. We also are using Solidity version 0.8.3 or above, and if we don't use that versions, we are going to consider that as a vulnerability as well. As I said at the beginning of this live, this is a great chance for you to test your fuzzing and formal verification skills. Formal verification, as I said, is a way to prove that the mathematics, the inner mathematical logic of the function work as expected, and especially here that we are using assembly code to interact directly with the EVM, and these are 100% pure mathematic functions. Well, formal verification is your way to go. Also for fuzzing, if you don't know what fuzzing is, go and check our blog, Cyphering blog, and we recently published an article specialized on what is fuzz testing and invariants. So you might check that as well. Of course, I want to always recommend you to check as well Solidit because it's the best place for you to learn about the latest vulnerabilities on the smart contract landscape and hone up your skills as an auditor. We hope you enjoyed this first flight because it's something different we haven't did yet, and that's it, more or less, the presentation of what this first slide is about. So I'm going to just wait some time here if we have any comment or question on the live. Let me check that out. GM, everyone who joined, thank you very much for being here. So let me also answer here with the GM. So if we don't have any questions about this first slide or how to perform the audit, again, remember this is meant for hone up your skills as a formal verifier on the specifics on the math behind of the functions. Otherwise, remember that if you have any question, you can always contact us through Discord and always leave a comment on social media. We are going to be glad to answer. Remember, you have 1 week for this first flight, and yep, that's it. Thank you very much for joining, and I'll see you on the next occasion. See ya.